Start streaming. There we go. And so the purpose of this is to give you an idea of the instructions. So if you have any questions about it, you need a non-graphing calculator for the exam. So if you've gone this far, you haven't gotten one, you are going to need one on that day. Otherwise, you'll be doing long division by hand, which is not going to be fun. You will get a data booklet. So you don't bring in your own data booklet. Pencils, erasers, please don't write it in pen. The marks on there are rough, so that those could change, but that's roughly how it normally is in terms of multiple choice to short answer. If you turn over, there is a choice section of the exam in which you answer some questions, and so we'll give you a selection, and this example has answer 3 of the following 9. So we'll give you a bunch of questions. This allows Mr. Snow to put on questions that only the AP class has done, for example. And so we can put any questions in there that one class has done a little bit more of than the other class, and then they can do that. There will be questions that in there that you can do. Pick those ones, and then you can do it. Obviously, these aren't chemistry questions, but they're just to show you the examples of what it would look like. Only do 3 of them. Now, that being said, if you've got time at the end of the exam and you do more than that, I can consider them. If you say haven't done very well in a different section of the test and that question covered the same material, I can look at that and use it. But do what you need to do first, and then only do extra questions if you have time. And then approximate breakdown of the material, so by topic. The percentages won't add up to 100% because they themselves are an estimate, but just roughly what it's been in the past in terms of how much material you're going to do.
I have a question. When
Yeah.
you have the choice here of the questions and you want to answer more, would you get extra points?
So you don't so much as get, proficiency scale. I can see if it improves your proficiency on that particular topic. So if you do a question that you didn't do as well as in a different section of the exam, I can use that to increase your proficiency. They're better than I thought they were.
Choose 3, for example, 4 or 5.
Yeah, you don't just add points. I consider whether it improved your proficiency. So it absolutely can help you. If you're already extending in the other area, it can't help you anymore, but it could help you. Yeah. Yeah. And I can say it has helped students in the past where they've done a question that I was like, actually, they're better at this section than I thought they were based on other spots in the exam. Question? Taylor? Oh, I thought you put up your hand. Yep.
It says that organic is part of the test, but we have
Organic, if you notice, there's a core topics and with options. Organic's not part of the core, so it is an optional. We may get to some organic and we may not. So they'll definitely be in the choice section. Yeah. Gas laws, it's something that used to be part of the course. It isn't anymore. AP definitely does it because gas laws are an integral part. The only part that we've done is 22.4 liters per mole. So that's ideal gas at standard temperature and pressure. You can also do ideal gas at non-standard temperature and pressures. If we have time, I can show you the formula because it is a very easy section to do. But it's another formula and it's another couple of days of just going through stuff. So, yeah. Your book doesn't really have it, but your big, thick black one would. The one that's probably on your shelf and dusty. Any other questions? Okay, keep it. If there's any part of the instructions, we just want to make sure the instructions don't provide a surprise on the last day and you have time to go through them. Okay, we were last day. Yep. I don't know. You'd have to ask the test center. I think it's open Monday, Tuesdays, and Wednesdays, possibly Thursdays. I don't think it's open Fridays.
Because we still have to write our contest.
Yeah, sometime this week, but the library should know.
Okay.
Yeah.
So we're writing a pro.
They changed the days at some point this year. So last day we did formula equation, complete ionic equation, and net ionic equation. Formula equation, then we've got sodium chloride and silver nitrate. What I would like you to do, because this is the very next problem. Where's our data booklet? Yep, one that says Golden Law on the front. Open up your data booklet. We're going to do this in a moment, but you might as well start now and turn to this page, solubility of common and compounds in water. Couple of definitions. Soluble means that will dissolve and you will not see it precipitate. Low solubility means that in water it does not want to dissolve and you will likely see it precipitate, except for incredibly small amounts. The table is set up so you look up the negative ion and then you look up the positive ion. So looking at that, is sodium chloride soluble or low solubility? Soluble. You would take the chloride, looking up here. You'd look over and you go, oh, with silver, lead, or copper plus 1, it has low solubility. With everything else, it is soluble. It is also really important that you look at the exact identity of the ion. It is only low solubility with copper plus 1. If it's copper plus 2, CuCl2, it's soluble, it's fine. And so whether it's copper 1 or copper 2 makes a difference in this chart. Everything else, soluble. Silver nitrate. You go down, look up nitrate, soluble with everything. Now, a couple of things to watch out for. Oftentimes, I'll look up, say, sodium sulfide. Is sodium sulfide soluble or low solubility? Yes, but is sodium sulfide one of those things? So students will tend to put sodium sulfide low solubility because they don't see sodium up here. Sodium is up here. Where is sodium in this line? Alkali ions. They list the alkali ions for you at the very top. They're lithium, sodium, potassium, rubidium, cesium, and francium. It's all that first column there. But for all the later ones, they just say alkali ions and assume that you know what those are, so you can look them up. So with these ones in particular, where they say alkali ions, low solubility, or alkali ions, soluble, and all others, low solubility, in particular, you've got to double check that it's not in the alkali ions, because alkali ions are soluble with everything. So whenever you see sodium, it's going to be a soluble compound. So with that being said, I would like you to predict the two products of this reaction, figure out which one's aqueous and which one's solid or low solubility, and then write out the formula equation, complete ionic equation, and net ionic equation. I'll have you do those on the board in a moment. I'll just pull up some groups, but you can start working on it now. No one that says, yeah, golden on the front. So we got Brenna, Carla.
Because I wasn't here the last time.
Yep.
I have some question. What does Netherlandic equation mean?
We need to cross out all the spectator ions.
And what are spectator ions?
The ones that occur on both sides. So you have them underlined there. 2 sodiums, 2 sodiums. 2 nitrates, 2 nitrates. They're on both sides, so they're just spectators. They're not taking part in the reaction. They're identical on both sides.
Okay. What is
I'm just going to get everybody into groups, and you're going to be doing this next question on the board. So I think that will explain those particular examples. Cole. Oh, there you are. Ella. Farina, Joseph, Juan Pablo. There you are. Katie. Kiara. And Kiki. Michael, Sabine, Sonia? No, Sonia. Taylor, Theo. Oh, there he is. Valentina and Wesley, I could have sworn I saw. There he is. One, two, three. That's 1, 2, 3, 4, 5, 6, 7. Yeah, we got enough room. Okay, those are your compatriots. Grab a whiteboard pen, a spot on the board. Taylor, you're by yourself. I will allow you to join another group, or you can dazzle people with your brilliance and do it completely on your own. I leave it up to you. Yeah, do it on a board. That way people can peek at other people's answers and help themselves along as review. You have to use the solubility table now and figure out which one's soluble and which one's low solubility.
It's a single replacement.
Nitrate's not N. Double check that.
Okay. If we have to like write it like
It's NO3.
we have NA. I mean like
No, it's a double replacement. I was just gonna say. Oh yeah. So yeah, we do. So you write on the chart the difference between the type.
So let's write the ions
Retake is on.
because NA.
Above it. Now we actually use the booklet. See which one is good. Wow. NO3 and NA are both soluble. Close, but it's not the same. Okay, and then so we are looking.
Should you have charges on your phone? That's
AG is
That's pretty good.
yeah,
But no, you have formula. That's the formula equation. And now you have the net ionic equation. Sorry, the complete ionic equation and the net ionic. Oh no, you don't.
now we don't have to talk.
Now the complete ionic equation, where you expand everything out, and then the net ionic equation. Yep. Once you've done the formula equation, do the complete ionic equation.
What's the complete?
The complete. I'll show you last days that you did. Let's minimize that. So reminder. That's the formula equation. The complete ionic is when you take everything that's aqueous and you separate it out. Solids don't get separated. They stay. The net ionic, after that, you can worry about it after, but you remove everything that's the same on both sides, and what you're left with is the net ionic. So first do the complete, that is everything, then do the net. If you think you forgot the complete, call me over.
Oh yeah. No charge.
Okay, so we have.
What do you mean no charges? They're separated. Do they have charges? So, like the only reason these don't have charges is because positive and negative are. So the whole thing is zero. But once you separate it, then they do have charges.
So do we cross out any of the last?
It's the next net ionic equation.
Very clever. Now we can do it with this.
Cl minus plus 8 plus
Okay, so we basically now mostly, yeah, so it's NA and A and so we basically.
Yo, Kiki, you got an eraser over there? Potassium sulfate with
No.
calcium nitrate.
Excellent. You're missing charges a lot. I'm just curious. What things would have charges? Ions. Right. So like AgCl doesn't because the positive and negative cancel out. But the ones that so in your complete ionic equation, they should all have charges except for the solid. Once you put them in, turn the page, do the next one.
Calcium sulfate.
Excellent. Turn the page, do the next one.
Yeah, guys, next one.
Yeah. You have Cl minus, and then the aqueous is like really spaced apart, which is just weird. That threw me off for a second. It should be a subscript, but other than that, it's fine. Look good. Turn the page, do the next one.
Calcium nitrate with
Turn the page on the thing. You've got another question that isn't all 1-to-1 ratios.
Mr. Neufeld, with potassium sulfate, what does that mean? Like with, is that just plus?
Yeah. English.
Then in the
I
one,
know.
last one the plus, and now you do with.
Yeah.
Okay, well,
If I say that somebody is with someone, what do I mean?
together.
There you go.
But they're not together, they react
Well, they're-
with each other.
Yes. Because if I say so and so is with someone, they're together. They're reacting.
No,
Yeah. Yeah.
calcium is Ca. Second row. nitrate is NO3. But calcium is negative 2. And now we have potassium sulfate. Potassium is negative 1.
Okay.
What is
We have
sulfate?
calcium nitrate. Calcium nitrate magnesium. Nitrate.
What you gotta do? Where's sulfate?
So we have CA with this CA in the first somewhere.
This there. Why is it negative?
No, you don't add the bracket.
Of potassium.
Like in this one, we like
Oh, potassium is positive 1, so we need and sulfate. SL
right.
Why did they write it?
Oh yeah.
CaSO4. CA is positive 2. SL4 is negative 2. So that is perfect. K is positive 1 and NO3 is negative 2. No, negative 1, right? Okay. So it's
Oh, but we need to replace it.
and now we have 2.
Okay, now let's check in the solubility.
Now
Okay. And then check if they're
So first of all,
soluble
we
or
check
not.
do we see calcium? Calcium is sulfate. Sulfate and calcium low solubility. So this one will be mass.
Slow down.
All of the potassium is solid. Nitrate is solid. So we have here, correct? Okay, now let's write the ionic
Dus
equation.
nu kan je zien
So we have
wat
Ca plus 2 plus.
Oh, excellent. You got the balancing in there. Got the balancing in there.
oh wait, no, we have
Now,
the first two.
your
What's 8
prediction.
and what's not 8.
Which one is solid?
So
Needs work.
How do you know which one is solid?
You use the table. The solubility table.
CA.
Oh.
Table I just showed you.
If it's not soluble, then it's solid.
If it's low solubility,
Yeah.
solid. If it's soluble, then it's dissolved.
Yeah, it's 2 plus low solubility with SO. That's NO3. NO3 is sulfate, right?
We have
No.
2
What?
and 6.
No. Look at your solubility.
No, it's calcium.
NO3 is nitrogen.
Yeah.
Everything else is
Well, what we have here, we have 2.
Okay, so that's 8.
cancel.
Oh, good. You got your right solids
So
there.
we need a 2 in front of
So
here.
erase
because
that.
we need
Then
now-
erase
Just this.
Because
and
we
then
have
So K is our positive one. SO4.
we have 2 in front of here, which
Two.
makes
SO4 2
4,
minus.
which makes
Is it soluble in K?
12. And then
Oh,
this
yeah,
one,
put it
Yeah, it's soluble.
Yeah.
You know why?
okay,
Oh, because here
Which one's
it's
solid?
because of negative I, SO4. And it's
Why is that one
soluble
solid?
in all except for those.
How are you
That's in your case.
are you looking at your table?
CaSO4.
So what does it say beside, like, so for that first one, calcium nitrate, what does it say beside nitrate?
Yeah.
is that solid or not? It means aqueous. Yeah. So why are you erasing it? Oh, for the next one, yeah. But you also need to put the symbols in the first one. Aqueous, you know. Yeah. And then for the next one, you need to put it and then identify which one is solid. For which one? So with which chemical? So you have to go through and do that with all of them. So you got the two on the right to do as well.
Yeah, but you have the wrong formula. Potassium nitrate is KNO. Oh, this is potassium.
That looks right.
1 second.
Is that another one? There's,
Because SO4 has 2, right? So now let's balance it again. So we have 2.
no, SO4 doesn't have a 2. Warte, du kannst die zwei einfach rausgeben. Also Ca2SO4. Just get rid of the 2.
So now we have to say, yeah, now everything makes sense again. Okay, so now let's write this again. So we have CH plus K plus Okay. And now we have so soluble
Post mullet.
and SO4 which was
Lost guy in Taiwan. Huh? You? No. How are you gonna get like your hair?
Wait, what are you doing? They said if you make copies, Sure.
How are you gonna make a mullet with your hair? Are you gonna straighten it or something? Like with a hair
If you do it, and then get like those lines in it on the side.
You can't get a mullet with that hair. That's just like I'm getting a mullet. No, I'm not. Yeah. I'm getting a very short haircut for 6 years. So I'm faster, fat, water.
So it's gonna be
I'm not getting a bus cut.
Why not? Get a bus cut.
I think you should get a bus cut.
Damn.
Be careful, I'm gonna give you one.
Damn.
When I come with a razor, shave your head.
Should we just grab all the credit cards? You cannot tell.
I'm not getting a bus cut. I can show you what I want.
What?
Yeah.
Everybody does. You said you're starting for next year, right?
But something like this.
Okay.
Basically, what I have done very short.
Wait, you said you were gonna stay for next year.
Yeah.
You charges or
Rats get
on the last one?
Nah.
like for like the last week.
Nobody's gonna do that. Nobody's
Try
gonna
and
do it.
convince them to all get hospitals.
What's wrong with the time?
What's your net?
It's like
I'm sorry, but like
You need your net?
Do you write
the
no
short
spaces?
cut
Do you
is
write
sticking out.
the 2
The long
to
part is
balance it, right? You write 2
I mean, I have
plus
a-
or write
Turn it around.
Can you write what?
like the sorry.
right here.
Can you write the
I have like my 2 minutes.
2 here? Do you
Yeah.
write that?
Yeah. you write aqueous next to each one, I can't see because Corinne is in the way.
Yeah.
During her time. You put aqueous next to the sulfate as well. Yeah, it would go next to all of them that are separated. You're missing all your aqueous signs in your computer.
Oh, we have to do it when they're like ions?
Yeah,
Oh, okay.
yeah, write them all out.
Now?
Yeah,
I've
Go.
written the most.
go.
Where's JP? Yes. All ions. I did all of it though.
Where's?
Just redo it completely from scratch. I can do it.
Okay. Couple of points. You need to make sure your aqueous signs and your solid signs are next to every ion in all of the equations. So if you're doing the complete ionic, that's a lot of aqueous signs all the way through. You need to keep it through. Most of you have kept your balancing properly through, but if you didn't, let's see if I can find one that didn't. That one looks good. Your net is still missing.
It's right there.
No, you just said net equation. You just said the word. Here, it's not wrong per se. But for example, when it says K2SO4, that 2 comes down and has to go in front of the K. Some of you have that, which is good, but you need to keep the balancing. So there's 2 up here, there needs to be 2 down there. It's separated, and you've got 2 of them. When the nitrate comes off, you need 2 of them. That is, looks like the 2K is there, but the nitrate doesn't have it. So you need to worry a little bit about your balancing, make sure that they cancel off. This one looks like it's done well.
Why is the nitrate doesn't have that?
The nitrate has 2 there, 2 there. Nitrate has only 2 there, but it looks like only 1 here. So you need a 2 in front of there. Now for the next section, now that you're getting a little familiar with this table, I would like you to improve this table. It's missing 2 ions. It is missing barium plus 2. And it's also missing chromate, which are 2 really common chemicals in the lab. Let me just double check that that's the one that I'm looking at here. KCl. There we go.
Where should we put that? On the K.
CrO4 minus 2. So chromate and barium. What I would like you to do is find out where those go. So for example, does barium, it says alkali ions are soluble with everything. But this table doesn't include chromate. So are alkali ions sodium with chromate? So I could take, let's see, I think I saw sodium. Here's potassium chloride. And potassium chromate. Take both of them, put a little drop on there, little drop on top, and wait and see if there's a precipitate. And do I have to walk up and see? Because I'm going to ask you to do all that, I want you to add in barium in the right spots where it does precipitate. Keep the alls if it actually is all. We only have these chemicals, so you need to find the right ones that are in there that allow you can test this. We've got strontium, So you can test some +2s. So you can double check that strontium, for example, is low solubility with sulfate. So you can take strontium, and there's some aluminum sulfate here, add them together, make sure that it actually does precipitate. So as I'm going to go around, I'm going to ask you to show me a precipitate. Grab the right chemicals based on that chart and show me that you can make something precipitate. Add in barium and chromate onto your table where it shows you get a precipitate and where it doesn't. So go through the rows where you can and test. Yes?
But barium is on the table, right?
It is in some spots, but it's not on there with chromium. Chromate. So that one you can just double check. Oh, it's there too. Maybe barium is on this table. It's been updated. Never mind. You're only checking chromate. So with barium, you'll just be able to confirm. Chromate, I think, is nowhere on here. Let me double check that one. Nope, chromate's not on there. So chromate's the only new one. The other ones you just have to double check. Show me that when I come around, you can say, okay, here's a precipitate. I checked it on the table. These two should precipitate. Add them together. Show me that they do. Grab a paper towel, because you'll be wiping this up. We are working in here today because Ms. Lawrence has booked the entire lab. Not because they're using it. They're doing a sound lab. And it needs to be absolutely silent. So, I would also ask you to be quiet while you're doing this. You can just work in your groups as you are in your rows. Each row can grab a glass plate. Where did I put these? 1 second. Where's the rest of these? There's a big, huge. Oh, it's in the back. I turned it around the wrong way. And then one of each of the chemicals. Yeah.
So we just test if it says all here, we
Yeah.
test if it's actually true.
Yeah, you can just add them together.
But we don't test this because it's
You
not
can
nitrate.
test nitrate. We've got some nitrates in there.
But chromate is negative, right?
Right. But if I come around and say, show me something that doesn't precipitate, you know you can grab any nitrate with any other,
Do we
type
grab
of thing.
each
You know
of
that it's
those?
soluble. Pardon?
Do we grab one of
You can grab one of each.
Okay.
If we don't have enough for each row, then I'll ask nearby rows to share, but I think we have enough for each row.
What is
We have like
this?
6 rows, and I think we have 6 bottles. Be very careful not to stain the carpets, keep it on your desk. And now while we're getting this together, please clear everything off of your desks, except for your data table and a piece of paper to write things down.
Do we have just
It's not really a lab, it's more like plain chemicals.
we just have H plus?
Oh, and the piece de resistance, of course.
have everything? It's just
Bro, what do we have to grab? Listen to this. This looks appealing.
Fluoride or
Okay, let's start with this.
Yes.
So those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do we have 10? No? This is 2.
Where's chromate?
Val, do you want
I think he's bringing it in.
look at my
Ja, aber hier gibt es nämlich die ganzen Sachen, die auf der Tabelle sind, oder? NH4, wo ist das zum Beispiel?
Once you have your chemicals, also grab a pair of goggles and clear all the papers off your desk. All papers, no binders. No computers, no books, no photos.
Where's the chromate?
Get out a piece of paper, and you're going to adjust your data table.
Where's the chromate? Like, I thought we need the chromate.
Yeah, there's some bottles coming. There's 0.1 K2CRO4. That's chromate.
Braucht ihr wirklich so viel?
Yeah, do we grab 1 each?
Nein, das will ich nicht.
You
We
got
need one from each?
one for each. That's a chromate.
Okay, last.
No, one from each bottle. Like we have 4 now, but do we need more?
These tell you which ones we have. It may be helpful to share between groups so we don't have quite as many bottles of some types than another.
Why not?
Okay. And where's chromate?
It's the one with chromate CR04 on it.
I have not seen that one.
You're holding it in your hand.
But it says Na2, doesn't it?
Yeah?
That doesn't matter.
Well, can you ever just grab a hold of pure chromate CR04 minus 2, or would it have to come with a partner? Yeah.
We don't have
Can you get me gloves?
Goggles on. Taylor, everything off your desk. Joseph, everything off your desk. Before your question.
Can you get me some gloves? I don't know. I have no idea.
In your bag. Someone will
Should we just try it out?
I know, sad.
I'm missing one. Do we have K2CR? Hey, wait.
You have to have a table and a piece of paper. That's all okay.
We're missing one.
Yeah,
and I
and a
don't
piece of
know.
paper, and a pencil.
Do we have some ACR?
Yeah, basically. You're mixing them with intention.
Should I grab more? There just might not be enough.
We need some paper towels.
But you're using your table to figure out will it precipitate or not, trying to predict. And if it's a chromate and you don't know, then you're adding it to the table. Did it? And you could also add some of those together to confirm the table. But I am going to ask you, show me a reciprocal. Pick the right thing together. You should be able to.
You want it like this super extra super.
Goggles are right there. Goggles are on the couch in the back. If you don't have them on yet, please put them on.
Oh my god.
No, that's small.
Special
Small?
There's kind of
Mine. I just grabbed
Okay,
two.
goggles on.
Alright, you got me the small gloves too.
Katie, you have goggles? They're getting them. Do we have goggles? Yes, goggles in the back couch.
Okay, so what do we do now?
You're just mixing them. You want to update the table, and you also want to be able to prove to me that if I come up to you and say, show me a percentage. What is it?
It's a thing that So this is our. Okay,
So,
so.
we have chromate and Na2.
Goggles on.
This new filter we mixed
And
it.
then.
Yep.
Let me see this.
Which mix on it?
Sodium.
Uh,
Here.
CR. No. Wait a second.
But any
Yes.
of those
So how would you adjust? Which row would you adjust?
negative. So we can
So,
test with
well,
NA and
that says all alkaline ions go with all negative ions. This is an alkaline ion, and I went with the negative.
You're looking at the sulfate section.
No, this
What
one's
did you
fine.
mix together?
Now we have to test this with H plus. Where's H plus? Do we have? Fella, have they got H plus?
And which row were you looking at?
You guys have
Well,
something.
you were pointing
You
at
have
this
like
one.
10 different things.
And there's no sulfates in it.
Oh, so it's okay, this, okay, so then it would go here.
No.
No, they don't. We can't test this one.
There's chloride, precipitate with potassium.
Three now. Do you guys have anything with NH4?
Now, this is set up with a negative line, right? So you need to add an extra one for chromate.
This is chromate.
Olympic.
At the bottom of your table, you should add an extra row for chromate. It's done by the negative ions, and you don't have a chromate row. So you will need to add one.
What do you have? What positive ions? Positive ions are always first, right?
So, chromate is negative, correct? So we tested with Na, where is it?
There.
NaNO3,
Yep.
because Na is
Says
plus,
it
right?
doesn't.
NA's there, yes.
So we can take it for the first
with-
row.
Okay, so
And you'll need to add a chromate row at the bottom.
Very salty.
Yeah.
Wait. We'll just mix
You
those
just
together.
basically
And then
And
this
see
is
if
the
we
solid
say-
mix
part.
it with
Okay.
Chrome.
Did it precipitate?
We'll just
Or
see.
this,
What is that called?
You see it's solid.
Oh, no.
It's not low solubility. If it didn't precipitate, what is it?
Is it not?
It's soluble.
There you go.
Well, I don't
So
Wait,
know.
what does
can we,
precipitate?
when it's for any, like,
Oh, that there's
sodium,
clumps.
can we say we're for iron?
You might be able to make that inference. Can you check it against, say, potassium to double check?
Well, potassium is
How
around
it's
here,
soluble?
and it's
Like
soluble.
low.
Oh, it's soluble, so you already know that. Yeah.
So I'll just assume it's all.
Yeah, you can make the
Okay.
assumption. Or you could say the ions. It's up to
Yeah,
you.
let's do it.
Is that precipitate?
Is it?
I don't see it.
Now I'm
We can't
the
do it.
first one.
I have no idea.
Okay, so
I think
that's
it's just
because
one
that
solid.
What do you
also
think?
means
Is it
it
as
works
clear as
with
it was before?
NO3.
No,
It's not mixing that one.
I think it's a little bit.
Yeah. Yeah, that looks like a precipitate.
Okay, so BA
Oh, but
does not
NO3 is negative,
is
so
not
I'm just kidding.
soluble
That's
with
because of the sign.
There we go.
okay, so
Have you added an extra row in the bottom?
Yes.
So you're gonna want, similar to the other ones,
We have anything with hydrogen? No, we don't.
you're gonna want a soluble and low solubility
Do we
section.
have anything with NH4?
Ooh, lovely precipitate.
Oh, that's nice.
Well, I see a white milky solid in there.
Okay. Oh, so that's
It's not clear
So
anymore.
it's low soluble. So low
Yeah, so
soluble.
it's low
Do we have
solubility.
something with
How do we? Wait, I'm kind of confused with how to write it down.
So, you see how these are written down?
Yeah.
You've got a negative ion and then you've got a soluble and low solubility section. So you should make an extra row, chromate of soluble, low solubility section.
Okay, so then if we mix it with BaCl2, then BaCl2 will be on the
does
solubility.
Now, is it BaCl2 that's this low solubility with?
Yeah.
Because you have two possibilities there.
Oh,
You could have had,
BaCl2.
you could have had the Ba
yeah.
react with the chromate. You also could have the sodium react with the chloride. Is sodium chloride soluble?
Yeah. Yeah.
Yeah, so you know it's not that one, so it must be the barium. Does that make sense? I am going to print this. What page is this?
Wes, have we done aluminum?
6.
Okay.
Yeah, I think that's right. Right, okay, perfect. No, soluble. Yeah.
So,
yeah.
I don't think we have anything like acute barium, just barium too.
Okay. Testing.
Oh, yeah.
That's just BA again. We don't need.
Yeah. Yeah. And then Na is also off.
Okay. AL. That's Na and CL.
Yo, do you guys know aluminum?
Yeah. Okay. So.
Yo.
Aluminum. No, we don't. Oh wait, yeah, we do, but we're using it right now.
Okay, after you're done.
Yeah.
Which one is this one? Okay, so we know we're going to do that.
But that's the problem. because
Let's just mix it together. That's fine now.
So let's say with barium.
Doesn't look like it, right?
So what's soluble?
So it's soluble with AL. Oh, it's AL3 plus. The CL is one negative. So AL.
And then we had SR2.
Okay.
And that was soluble.
Press AL, please.
Yeah.
Well, I'm guessing that Na.
We need to get ethanol that we haven't had yet.
Yeah, put the yellow thing.
BA and 3.
But then do we have the Na?
BaCl2.
Put on.
Chromate doesn't have an Na.
KCl.
Well, it-
Check where,
They're all soluble.
Now we can take
Yeah, true.
Tested it with an AM.
Mr. Your phone?
Yep.
I think I could quietly go in the lobby and grab more from that.
Oh, I'll go grab more paper towel. Miss Lawrence is a little freak with someone who
The only one we haven't done is SR. Do you guys have SR?
Yeah, we do.
Yeah. That's the last one we have to do. Huh?
You don't even need to do one and everything else.
You can do it.
NH4, do we have
One drop. I'm getting another one that everything we haven't done
With the same starting.
because we've done this one. It was a few rounds.
still gotta wait though.
Yeah. Was this SO4 in the chart? Was this? Yes, I said. -2? That's it, right? Okay. So that's it. Negative 1 is that positive July of the 3.
Guys, how do I check?
Okay, now we've done everything.
Which one is this?
No precipitate, right? Yeah, so that's that was SR.
You mean
SR.
Didn't we just check that?
Yeah,
Oh, it's still on there. My bad. Okay, I brought sodium again. Because I believe we have
But
Yeah, probably. As long as we have like SR2.
let's have different sets.
That is fine, right?
alpha, ion,
Yeah,
soluble,
yeah, I think so.
barium, low solubility, SR, and AL.
SR AL soluble.
Yeah.
They wanted me to be
Was
so
that
quiet.
key? But it has to be.
More paper towels? Okay, I'm gonna come over and ask you then.
Well, this is two plus.
I want you using your table to show me a precipitate that is not chromate.
But like, it's already NA2, so I just feel like we don't need to test it.
So you help? Is that good?
Okay,
But
let's
not a
check.
chromate. I want you to show me a percentage that's
What
not a
else?
chromate.
So let's see, we have participant.
Oh, like not using chromate?
Yeah, different. I wanna see the utility table.
That's fine. Oh, I got it.
You can check that.
Oh,
Now you want to say, and now you want to say precipitate that is not.
not chromate, yeah.
I can do that. I mean,
It's a positive.
SR is. Okay, Mr. Newville.
Okay.
We're ready. Okay.
Yeah, exactly.
So we can leave that. So we tested those two. I would just
Okay. NaSO4.
Yeah.
no soluble.
Where's SO4? SO4 and EA.
Lovely.
Checked everything.
Now show me one that doesn't precipitate.
Mr. Neufeld.
Sherifeld? I'm about to show you a precipitate.
We can watch two at the same time.
So we have a drop of this.
So like CL. Where? So I would SO4.
What's the charge on it? No, it's
I would
positive.
here first, right? So I want SO4.
Smoky.
Yeah, SO4, and then I would here.
It is. Now show me a pair that don't precipitate.
Sure.
We don't need that.
I'm gonna go get up on street.
I just grabbed the wrong one.
EA is good with sulfide, so S. And NO3 is good with all.
Wait, these down, clean up, put the bottle back. You guys are good to go?
We checked
Oh, have I saw your table as
Oh,
well.
okay.
That's what
I
you're
guess
saying.
it is already.
We can leave?
No, not class. You're good to go in terms of
Listen,
using
you felt,
the chemicals.
listen, you felt we've got to go get prepared for today's assembly.
Yeah.
I've got to ready myself for Tommy's speeches.
Yeah.
Oh, Tommy has a
And
very
for the open house video.
weird speech today.
Oh,
I'm
It's
I
very,
know the video.
it's very interesting.
Mr. Newton, I think we checked everything we can.
Okay, we're gonna soluble, no soluble. Okay, see you. Oh, excellent. Now, if you arrange it like the other ones, you put everything that's soluble there, everything that's low solubility there, but you should have one thing that's low solubility with. So we could vary, so we vary. So you're good. Now, I want you to show me
This one would
a precipitate without the chromium.
something that doesn't. Okay, you got it. Over there with
So,
the paper.
using your table, pick two things you know will precipitate and show me. And then I'm gonna ask you to pick two things
We
that
can
will
take
precipitate.
chloride
Have you guys made any tapes?
So we need
sulfate and
SO4 is good with not barium.
Perfect. Now I'm gonna ask you
Would
to
it be
show
good with
me,
AL?
so add two things together that precipitate,
AL.
but you cannot use a chromium.
Yo.
So should we use barium?
Oh, here, AlCl3. Cl3 with AL.
Now two
Does
things
that
that
work?
won't precipitate. Do you
Cl.
have the table?
Yeah.
Excellent. Now show me two things that will precipitate that aren't chromium.
Let's see about right here.
Oh, you're having it now.
Yeah, I'm just gonna go the other way.
Okay.
And
One, and you can do the other one.
Perfect. Lovely. Now, clean it up. Two things when added together without a chromium that don't precipitate.
Okay, easy.
Good job.
Right here.
Should we
We
do
did it.
that?
Excellent.
What if we do?
Excellent. You can now all clean up.
And leave.
And
Yeah. What about as one NA?
This is why you should never eat in.
As one
I was always like,
and NA.
but now I'm like, okay.
okay, clean up, wipe down, put everything up. Oh, have you shown me? That's gonna precipitate. And that's your non-precipitate. Excellent.
Mr. Newfeld.
Wipe it down, put everything back. Get ready to go.
What is the glass?
That's the non-precipitate. Excellent. Wipe everything down, put it away. We are good to go. Really? You can just wipe off the glass well. You don't need to rinse it and put it back in the container.
My bad.
Our next class
Yeah,
is
you're
going
bad.
to do a similar thing. And a little here in this one. Kiki, if you could put that away. Blood balloons. Although we used to make turkeys out of those for Thanksgiving. Yeah. They make really high frequency noises, and then one of the waves that make them do that. And any other sound will make them
Oh, wait, listen.
At times it actually, like I was in a shoe
Now you all
out of the window. I was
Oh, okay. I like having those in my hands.
No, those we're gonna sterilize those.
You think you're funny? Don't scrap.
What? No, we're gonna continue on. Let's say you're on. You're good to go in terms of the lab. Not good to go in terms of class. We don't leave till 9:35. We still got 10 minutes left. Over. Once your area is cleaned up, you can pull your notes back out. Kiki, what are you two doing? Wesley. Kiki. Sit down, pull your notes again. Wipe it off really well and then put it back. There's paper towel right there. SPD in terms of order going that way.
Now, in what order do they lose electrons when you have an ion?
Oh, P before. Hold it. When you take them off, you take off the. It goes S, D, P, and then you take them off. PSD.
PSD?
Yeah, because they're the outermost larger number electrons. Yeah, it's also in your notes. Okay. We have some definitions. What does the word dilute mean?
Water. Put more water in.
Put more water in. In terms of the word solvent and solute, which would you have more of if it's very dilute? Solvents. I've heard. I think this can only be solved with a vote because that's how science runs. How many of you think that dilute means lots of solvent? Kiki was going to vote, but he put it. Theo puts it. How many of you thinks that dilute means lots of solute? And none of you. Nobody voted.
I vote for salt.
Pardon?
We're all insecure.
That's fair. It's fair. You had COVID a couple of years ago. Nervous to speak out loud. What does dilute mean? Lots of water. Is water the solvent or the solute? Solvent. It's the thing that does the dissolving. So if it's dilute, you have lots of solvent or lots of water. So it's good to think of it in terms of water. Water is always a solvent. So dilute. Yeah, Kiki, you're the only one to vote for that. Well done. Except you put your hand away, so it doesn't count.
I put my hand up.
I always think of orange juice. If you ever bought concentrated orange juice, you dump it out, you mix it with water. My mom always said you put in 4 cans of water for every 1 can of concentrated orange juice. And it was only after I was older and I actually read the label, it turned out she was lying. It's 3 cans. I was drinking diluted orange juice for my entire life. So concentrated would be a lot of solute. Thea?
Sorry.
Thank you. Taking down notes? Yeah, there you go. Saturated?
Saturated means
Relative to solvent.
It does mean a lot of solute. If you, Theo?
I think saturated means it's not like that there's still that they're not soluble, like they're still like solid in them.
Saturated often means that there's still solid in there. Because if it's saturated, it means you can't hold any. Have you ever been in a class and it's like the last 10 minutes and like the teacher says like you can't go and you still have to do more knowledge, but your brain is full and you can't absorb anything? You ever been like that? Yeah, like right now? That means you are saturated. You can't take in anything more. So the knowledge is just like going all over the floor and hanging around.
Yeah, very saturated right now.
Oh, but it's your job to take it in and stuff it. Just make it super saturated, which is coming up. No more possible often has solid solute. Because if you add any more, it won't dissolve. If it's unsaturated, then the solution is able to take more. Now, you can get something that's super saturated, a solution that holds more than it normally can hold. You have to create them in a special way. You essentially heat them up. Solutions at different temperatures can hold different amounts of solute. Warm water can dissolve more than cold water, as I'm sure you're familiar with if you've ever cooked anything. And so if you warm water up and you dissolve more and then you very carefully allow it to cool, it will sometimes hold on to that solute and it won't precipitate out. And it will just sit like that. Now, you throw in a grain, you jostle it a little bit, it'll all come out at the same time. But before that moment, it's what's called supersaturated. So, practice. Using your solubility table, designate these as either soluble or low solubility. That's that one. B, pick an ion that is insoluble with those and come up with a method to separate those solutions or identify them. Do the definitions? Oh, sorry. Once you've done the definitions, you can turn to the next page and just start solving those problems. Next week, what's today? Today is Thursday. So next week on Friday, you will have a titration lab. You will be adding acids to bases until it changes color. It is a return to stoichiometry and doing calculations in that way. Yes, sir.
What is the thing after dissolving?
Pardon?
In unsaturated dissolve?
What does what?
What does the thing after dissolve in unsaturated?
Here?
No, unsaturated.
Wait.
Yeah, like the last part. Oh, good.
Yeah, I have answers. Theo.
For the last one, PBCl.
Yeah.
That is not balanced, is it?
Is it? I'm just gonna wait till.
P is 2 plus and Cl is 1 minus, isn't it?
Oh, it's CI.
PB. No, it's PBCl. That's not unbalanced. PB is lead, right?
Yeah.
It can be +2. It can also be other charges.
Isn't it Ci because the L and the I look different? Here, if you look at PBCl2 and then PBCI.
1 second. Juan Pablo, are you done with this? I don't know what you're talking about.
Wow.
Yeah. I probably text recognized it at one point and I got the wrong one.
Mr. Newfeld, when it says PO4 negative 3,
Yep.
and down here it says it's low solubility with all others.
Yep.
And then here, when I take, for example, potassium plus, and it says it's soluble with all other negative ions, what is true then?
So you go down here and you see phosphate,
Yeah.
and here you see alkali. Oops, sorry. I think we go here, right?
Yeah.
Phosphate is soluble with alkali ions. That's okay.
But what if I choose, for example, chlorine?
Chloride,
Chloride, I mean, sorry, yeah, chloride.
but can phosphate ever bond with chloride?
Oh no, it's not.
Yeah, they're both negative. Yeah.
Well, I can take copper.
I just picked something that wasn't. Yeah. Like I just picked like silver.
Like everything except the alcohol.
Mr. Neufeld,
Yep.
on C it says you have 3 solutions. Identify them. Do you have, like? Does that mean just name them?
You have 3 unknown solutions. You don't know which one's which. So imagine there are, for number 3, imagine, C, if you will, you've got 3 bottles. The labels have fallen off. One of them sodium sulfate, one of them sodium sulfide, and one of them sodium chloride. How will you figure out which one's which to reattach the correct labels?
Explain how to do that?
Yep.
Oh.
Using your solubility table, you should be able to identify which bottle is which.
So we just say that.
Yep. And that question is going to be a homework question. I don't think you'll be able to get that all. You might actually be. 2 minutes left. If you're very clever with the table, you could probably solve that right now. But if you don't quite finish, it is for homework.
You need to solve it. Like I have to say what they
They're all
react.
NA.
Did you get this?
Like they're already named, so it's like.
Oh, okay.
Imagine them tags fell off.
This is a problem of the thing. I've got.
They all have
So
NA.
I just say what they're soluble with. And
I have 3 beakers. And we don't know what's in them.
So I'll just say what they're soluble and not soluble with, right?
Yeah, so how would you test them, the process, in order to determine which one's which? These are the possibilities. So one of them sodium sulfate. How will you figure out, and if it does precipitate, how do you know it's not one of the other 2? Oh, it is now 9:35. We'll go over this page next day. Thank you for your participation in an in-class lab light demo. You cleaned up really well.